What's going on, everybody? Welcome back to my YouTube channel. Now look at this nice and beautiful Olympiad question we have here on the board that we're going to be solving. And it says x to the power of y is equal to y to the power of x. Now let's pay attention to this little information we have here because it will help us in the long run. It says x and y are elements of real numbers, which means x and y are real numbers. And again, x is not equal to y. So let's put that into our mind as we go ahead to solve this question. So now what do? The first step we are going to take is we'll say let y be equal to nx. Very good, because this will make the question to be a lot more easier for us to solve. So that means wherever I see y, I'm going to be putting nx there. So let's go. This is x, so let me write x here to power y. So instead of writing y, I'm going to be writing nx. So let me write nx here equal to, now this is y, I'll be putting nx because that represents y, and it is raised to power x. So I'm going to be raising this to the power of x. Now I want what is on the left to look exactly like what I have on the right. This one is having a power of x, right? So we can do this one to resemble what I have here by writing it like this: x to power n raised to power x. Well, this is actually from indices, which says that whenever I have a base raised to power m, and this is again raised to power n, the base is raised to power the multiplication of the two powers. That means these two powers multiply. So that means when I multiply n times x, just as it is here, I'm going to be having nx. So it's still the same thing. Equal to nx to the power of x. And now since the left hand side and the right hand side are both having a common power of x, I can equate the base. So the base here on the left is x to power n is equal to the base here on the right, which is nx. Are you seeing that? Cool. So the next step is for us to remove x from this right hand side. And how do we do that? Is by dividing both sides by x. So I'm going to be dividing the right hand side by x and also divide the left hand side by x. Now notice x here will go off, leaving behind n equal to, now pay attention to what we have on the left. I'm going to be bringing a law of indices again, which says that when I have a base, let's say m to the power of m, dividing the same base a, but this time to a power of n, the law of indices says as long as they are dividing, take one of the base since they are common and subtract the powers. And this is what is happening here. The base on the numerator and the base on the denominators are the same. So I'm going to be taking one of the base, x, and the power here is 1. Take note. So since they are dividing, which is expressed by this all over, then the powers are going to be subtracting. So n minus n would be the new power. Are you seeing that? Very good. Now I'm looking for the value of x, but x is carrying a power of n minus 1. So how do I get rid of this power? Is by multiplying the power by its inverse. So let's do that. So x to power n minus 1, I'm going to be multiplying this power by its inverse, 1 all over n minus 1. Cool. And remember, whatever I do to the left, I'll also do to the right. So since I multiply the power of what I have on the left by 1 all over n minus 1, I'm going to be doing the same thing here. The power on the right will be 1 all over n minus 1. Now look what is going to happen. The power here will cancel this one here. Are you seeing that? So leaving behind x to be equal to n to the power of 1 all over n minus 1. So this is the value for x. Since I have the value for x, it is very easy for me to get the value for y. Remember what we said? Come here. We said let y be equal to nx. So all we are going to do is to substitute what we have here for x here so that we get a value for y. So let's do that. All right, recall that we said y is equal to nx, right? Very good. So now I'm going to be putting the value of x here. So y is equal to n times x. We just got x. X is n to the power of 1 all over n minus 1. So we're going to be applying the law of indices to what we're solving here. So y will be equal to, the power of this n here is 1. Take note. And from the law of indices, as long as the base here and the base here are the same, I can take one of the base. And since they are multiplying, that means I should add the powers. The power here is 1 plus the power here is 1 all over n minus 1. Very good. So y will be equal to n. Now, the LCM here is actually n minus 1. So I can put it there. I can put all over 1 here so that it looks simpler. So n minus 1 divided by 1 is still the same n minus 1. Times 1 is n minus 1. So I have plus here. N minus 1 divided by n minus 1 is 1. Times 1 is 1. So simplifying further gives y to be equal to n. Now, minus 1 plus 1 is gone. So leaving behind n in the numerator all over n minus 1. So this is the value for y. So let me write the two of them down. X, we got x to be equal to n to the power of 1 all over n minus 1. And we got y to be equal to n to the power of n all over n minus 1. So we can actually get the value of x and y, the actual value for x and y, by substituting for n. But there's something you should know. N cannot be equal to 1. So n is greater than or equal to 2. Or we can say n is at least 2. So let's say let n be 2. Let n be equal to 2 so that we get the value for x and y. So x will be what? X will be equal to n is 2. So I'm going to be putting 2 there. 1 all over 2 minus 1. Are you saying that? 2 minus 1. So this will give me the value of x to be what? To be 2. Because 2 minus 1 is 1. So 1 divided 1 is 1. 2 to the power 1 is 2. So that's the value for x. Now, what about the value for y when n is 2? So let's get the value for y. Y will be equal to n. N is 2 to the power 2 all over 2 minus 1. And this is going to give us 2. 2 minus 1 is 1, so 2 to the power 2 is going to be 4. Are you saying that? So when n is 2, we have the value of x to be 2 and the value of y to be 4. So let's try that out. Remember, our given equation is x to the power y is equal to y to the power x. So let's see if x is 2, we're going to be having y to be 4, if they are going to be the same thing. So x is 2 to the power y is 4, equal to y is 4 as x is 2. Now, notice that we have 16 equal to 16. So we can keep trying different values of n to get different values of y. So we are saying that the values of x and y changes as long as the value for n increases. Well, I hope you enjoyed this video, and if you did, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.